Okay, let's work through this problem here from a student. This is a classic systems of equations problem. I have it all written out here because I worked through it once while recording and then made a silly calculation error and it was not recoverable for the video, so I just finished up the problem and we'll talk our way through it. Now, I'm going to start up here after I've read the problem. So a boat took 5 hours to travel 60 kilometers upriver against the current. The return trip took 3 hours. We want to find the speed of the boat in still water and the speed of the current. So this problem really requires two things. And I just want to start by saying I really like these types of problems. A lot of people don't, but I like distance, speed, time type of questions. They're fun. So the first thing we need the relationship that relates speed, distance, and time. And often you forget it, and one way to remember it is just to say how fast you're driving in a car. So I drove in a car at 100 kilometers per hour, so I see that a speed is a distance over time. And often we'll say distance is written as speed times time. The second kind of conceptual understanding you hear is the idea of when you're traveling, if you're pushed with or pushed against. Because this still boat in water, so if you have a boat moving in water or even still in water, it's going to move either against the current or with the current. So imagine this guy on ice skates. This is a wonderful drawing, as you can tell. If they're skating at 5 meters per second and then their friend comes up behind them and pushes them with an added 2 meters per second, it makes sense that means their speed will be 2 meters per second plus 5 meters per second, resulting in a speed of 7 meters per second. Likewise, that same person could be traveling at 5 meters per second and someone could skate out in front of them and push against them at 2 meters per second. So again, if you're traveling at 5 meters per second forward and someone pushes against you at 2 meters per second, that means your actual speed is going to be 5 meters per second minus 2 meters per second, resulting in a speed of 3 meters per second. So if we let x represent the boat speed with no current, and I should actually right here, let c represent the current speed, we can think of the question. So this is the first thing I talked about. Now we say this. We can think of the question like this diagram. So the boat is going to travel from here up to some point 60 kilometers upstream and then kind of turn around and then kind of come back down. Okay. So it's traveling the same distance in both directions. When it travels upriver, if it's traveling at x kilometers per hour, it's going to be traveling into the current, meaning the current's going to be slowing it down, so it's minus c. When it travels back, it's now traveling with the current. So if the boat's speed in still water is x, that means the current's going to add some speed, so we say plus c. So we set up our two equations here. So our first equation is traveling upstream. So the distance, which is 60 kilometers, is speed times time. So the speed, again, is the speed of the boat minus the current, because we're working against the current, times 5. And so we rearrange that, so we get 60 as 5x minus 5c. And then the second equation is similar because we're traveling against 60 kilometers back. It takes us 3 hours times the speed, which is x plus c. So the current is now helping us here. So we get 60 is equal to 3x plus c, 3c. And therefore the boat has traveled at, oh, sorry, I'm not there yet, pardon me. Then I come up here. So now I write these two equations, and now I can just apply the process of elimination. So we're going to multiply the first equation by 3 and the second one by 5 to get this. So this is step 7 here. Then we're going to add these two equations, and we get this here, and we do a little algebra, and we end up with this. There's 0.8. So the boat speed is 13.6 kilometers per hour, and then when we sub that in, we work out the current, which is 9 right here, which is 1.6 kilometers per hour. And then there's our concluding statement. So that was a really quick kind of walk through this problem, and I hope that helped.